Hello students, welcome back to our channel. Students, in this video we are going to discuss a very important topic in vectors, and that is called the multiplication of vectors. In the last video we have seen that how we can add two vectors and what is the meaning of the vector which comes after the addition of two or more than two vectors. Now we are going to see what is the meaning of multiplication of vectors, how we do the multiplication of vectors, what are the formulae, what are the rules that are used in the multiplication of vectors. But main things first, multiplication of vectors is of two types. Multiplication of vectors is of two types. First one is called the scalar product, or it is also called the dot product. Scalar product or dot product, right? Second type of product of vectors is called vector product or cross product. Vector product or cross product. So unlike addition or subtraction, like when you add two vectors, you are going to get a vector quantity. Addition of the two vectors, sum of the two vectors will always be a vector quantity, and when you subtract two vectors, you are always going to get a vector quantity because subtraction of two vectors is also vector quantity. But that is not true for the product of vectors. When you multiply two vectors, you can get a vector quantity or a scalar quantity. So when the product of two vectors is a scalar quantity, then it is called the scalar product, or it is also called the dot product because it is represented by putting a dot between the two vectors. I'll just show you. And when the product of two vectors is a vector quantity, then it is called vector product, or it is also called cross product because it is shown by putting a cross between two vectors, right? So this is when the product of two vectors is a scalar quantity. Right? And vector product or cross product is when product of two vectors is a vector quantity. Now let's start with the scalar product first. Let's start with the scalar product first. Okay, suppose we have two vectors. Let us say we have two vectors A and B, right? We have two vectors A and B, and the angle between these two vectors is theta. Angle is always taken when the tails of the two vectors touch each other. When the tails of the two vectors coincide, then the angle between the vectors is taken as the angle of the between the vectors, right? If your one vector is like this and other is like this, then the tail of one vector is coinciding with the head of the second vector. So this angle is not the angle between the two vectors, right? Only this angle is the angle between the two vectors when the tails of the two vectors are coinciding with each other, right? So if we have two vectors and angle between them is theta, then their dot product, which is represented by A dot B, is the magnitude of A into the magnitude of B into cos theta. This is the formula for the dot product of the vectors. For example, work is the dot product of force and displacement, because force is a vector quantity, displacement is also a vector quantity, but work is what? Work is a scalar quantity. So now you can clearly see that work, which is a scalar quantity, is the product of two vectors. So it must be what? It must be scalar product or dot product, right? So here you will put the magnitude of one vector and the magnitude of second vector, and here you will put the angle, the cosine of the angle between the two vectors. So if vector A is given as a1 I cap plus b1 j cap plus c1 k cap, and vector B is given as a2 I cap plus b2 j cap plus c2 k cap. If the vectors are given as like this, without going into the derivation or other details, just remember that in this case the dot product of the vectors is given by a1 a2 plus b1 b2 plus c1 c2. So these are the top two formulae to find the dot product of two vectors. This formula will be used when you know the magnitude of the two vectors and the angle between them, and this formula will be used when you know the two vectors in this vector form, but you do not know the angle between the vectors, because if the vectors are given in this form, even then you can find the magnitude, but still you cannot use this formula because you do not know the angle between the two vectors, right? Okay. For example, let us say it is given that a force I'll just make a diagram and we will find the work done in that case. Suppose this is a block and this block is kept on a horizontal surface. This block is kept on a horizontal surface, and a force of, suppose, some Newton, let us say a force of let us say 10 Newton is applied at an angle of 60 degree, and this moves through 5 meter due to the application of this force. Then work done, which is the dot product of force and displacement, can be calculated as the magnitude of first vector, which is the force, into the magnitude of second vector, which is displacement, and the magnitude of displacement is 5. So what is the angle between force and displacement? We have seen that the angle between the two vectors is taken when the tails of the two vectors coincide with each other. So this angle is when you shift this force on the displacement vector, then you are going to see that this is the angle, which is the angle between the force and displacement. And if this angle is 60 degree, then this angle must be 60 degree, because both these are same angles, or we can say these are vertically opposite angles, right? So 10 into 5 into cos 60 degree, so 10 into 5 into 1 by 2, so it is 25 joule. So work done is 25 joule. So this is how we can use the concept of dot product of vectors, right? Now we are going to discuss the cross product of vectors. Cross product of vectors. Cross product of vectors. So what is cross product? When we have two vectors A and B such that the angle between A and B is theta, then the cross product A cross B is magnitude of A into magnitude of B into sine theta, right? Right? But wait a minute, this is a vector, right? What we are saying that product of two vectors is said to be cross product or vector product when the resultant vector, which is coming as the product of the vectors, is vector quantity. So this must be a vector. But this is what, this is the magnitude of A, this is the magnitude of B, and sine theta will also be having a real value. So this product is not a vector, it is a simple number. So it is a scalar quantity. So these two sides are not equal. This is a vector quantity and this is a scalar quantity. So what we will do? We will multiply this with a unit vector, suppose n cap, to make it a vector. Now both the sides are equal and we will say that n cap is the unit vector along the vector A cross B, right? Unit vector in the direction of A cross B. And direction of, since A cross B quantity is a vector, so we cannot leave it in the form of magnitude only. This can be left in the form of magnitude, but we cannot leave it in the form of magnitude only because this is a vector quantity. So we have to know, or we have to tell the direction of this quantity. So for that we must know a rule of finding the direction of A cross B, and that rule is called the right hand thumb rule, or right hand screw rule. Right hand thumb rule says, it simply says that if you want to find the direction of A cross B, then you simply have to put your fingers on A and curl the fingers towards B. And in that case, the thumb is going to give you the direction of the vector A cross B. For example, if you want to know the direction of A cross B in this case, you have to put your fingers on A and curl the fingers towards B. Then the direction of thumb, which is this direction which is coming out of the plane, that is the direction of the vector A cross B, right? So in this direction there is a unit vector n cap, right? In the direction of A cross B, that is in this direction, this is a unit vector n cap. So if you multiply the magnitude with this unit vector n cap, you are going to get this whole vector which is given by A cross B, right? And if the two vectors are given in this form, in the vector form, if the two vectors are given in this form, A is this and B is this, then how we are going to find A cross B? Then A cross B is given by the determinant method. You will just make a determinant, and the first row of the determinant should be I cap, j cap and k cap. The second row should be the coefficients of, what were the coefficients that we have taken? A1, B1, C1. Okay, not A1, A2, A3. So these coefficients are A1, B1 and C1, and A2, B2 and C2, right? So you will just make this determinant and you will expand this determinant. How we are going to expand this determinant? You will just write I cap and you will leave the row and the column which has I cap as one of the elements. You will leave this row and this row. Now we are left with these four elements and we will multiply them like this with this, and then subtract this product, right? B1 C2 minus B2 C1. B1 C2 minus B1 C2 minus B2 C1 minus B2 C1, and then you will put minus j cap and again we are going to do the same procedure. We will leave the row containing j and the column containing j, this and this. So it is a1 c2 minus c1 a2, a1 c2 minus c1 8, right? Okay, again we will put plus k. Just look carefully that we are putting positive negative signs in alternate positions, plus I cap minus j cap plus k cap, and we are going to repeat the same thing. We will leave the row containing k and the column containing k, and we are left with these four. So these four will be multiplied like this. So in the bracket we will write a1 b2 minus a2 b1, a1 b2 minus a2 b. So this is the formula for the cross product of the vectors if the vectors are given in IJK form, right? So this is how you can find the dot product, the cross product, the direction of cross product, and everything about the product of vectors. So this is a very important topic in vectors. You have to prepare it very carefully. I'll meet you in the next lecture. Till then, all the very best.